Alright, in this video we're going to be looking at the Unit 4 review for Algebra 2. We'll start with the first question of the review, which is asking us to tell which operations are open and closed for polynomial systems. An open system is one where if I do the operation, I get something other than what I started with. So if I do an operation with a polynomial, my answer will not potentially be a polynomial anymore. Closed systems are where if I try to do an operation, my solution will be the same type of thing that I started with. So if I started with a polynomial and perform the operation, my answer will also be a polynomial always, and there's no way to get anything other than a polynomial as an answer. Now, it's easy to answer this question if you know what would not be considered a polynomial, and polynomials are not allowed to have a term that has a fraction with a variable in the denominator. You could have a number in the denominator, that's fine. But as soon as you throw an x or a y or a z or any variable into the denominator, you run the risk of accidentally allowing the denominator to become the number 0. So if I have a function over x, x could be the number 0, and if x is 0, then my equation is undefined, and our polynomials are always going to be defined. So I can't have a fraction in the denominator. So if I think about starting with addition, if I start with a polynomial and add another polynomial, I start with something with no variables in the denominator and add something else with no variables in the denominator. There's no way for that to ever be anything other than a polynomial as a solution. So that's closed. It goes in a loop. I can't get something that's not a polynomial when I just do addition. The same thing is going to happen with subtraction. Even if I end up with an answer that's 0, 0 is technically a type of polynomial. It's a monomial. It's just one number. So there's no way that I can subtract and end up with a rogue fraction with a variable on the bottom. So that's also closed. Multiplication is going to give us the same scenario. If I multiply two polynomials, I'm not going to end up with some random fraction that I didn't start with to begin with. So that's also closed. So the only one that's open is division, because if I divide a polynomial by another polynomial, there's a very good chance I could end up with a variable in that denominator that doesn't simplify away. And as soon as I have that, it's not a polynomial anymore. So division is open. Everything else is closed. Let's take a look at question 2. This is asking us to find the degree and the leading coefficient for these polynomials. In order to find the degree, I need to find the highest power of x in the equation. And in order to find the leading coefficient, it's whatever coefficient that highest power of x has. So in my first problem here, problem A, the highest power of x is this one right in front, x to the 4th power. So that exponent 4 is my degree. So my degree is 4. The number in front of that x to the 4th, the 3, is my leading coefficient. So I'll just call it LC for leading coefficient. It's going to be the number 3, because that's what's in front there. Now my B example has things out of order. It doesn't have the highest power of x in front. It doesn't matter. I just need to find whatever has the highest power of x. So this, 4x to the 5th, has that 5 exponent, which is the largest exponent of x in that problem. So that's going to be my degree for this problem. My degree is 5. My leading coefficient is the 4 that's in front, so leading coefficient 4. For my next example, C, I again have things out of order. I'm not looking for the largest number as a coefficient. I'm looking for the largest power of x. So that's x to the 3rd power, so the largest power of x there. So my degree is going to come from the exponent 3. And my leading coefficient is going to come from the number in front of that term, which is negative 3. I have to include the negative because that's being subtracted. Last but not least, I have example D, which says that my polynomial is just the number 5. My job is to find the largest power of x, but this is only one term, and there doesn't seem to be an x. And that's because the x in this term has turned invisible. Just like I can raise x to the 2nd power or x to the 1st power, I can also raise x to the 0 power. And as soon as I raise anything to the 0 power, it equals the number 1, and 1 can become invisible. So this is technically negative 5 times x to the 0 power, and the x to the 0 has become an invisible 1, which is why we don't see it there. So that means that my degree for this problem is the number 0, because that's how many x's I have. And my leading coefficient is the number that's in front of that x to the 0, which is the number negative 5 that we see there. Let's go ahead and try number 3. Question 3, we have to multiply polynomials. So let's see how we would do that. When I multiply polynomials, for example, 2x times 3x, I get 6x squared. And that's because I can multiply the coefficients together to get 6, and then I can multiply the variables together separately to get x squared. And that's the same thing we're going to be doing in these problems. Problem A just has a few more variables than this example off to the side, but it's no more complicated. We just have to do everything one step at a time. So out in front, I have 4a squared b, and I have to multiply it by everything in the parentheses. So I'm going to distribute it inside. So let's start by multiplying 4a squared b by 3ab squared. So I'm going to take the 4 coefficient and multiply it by the 3 coefficient. That's going to give me 12. I'm going to take my a squared and multiply it by a. That gives me a cubed. And then I'm going to take this b and multiply it by b squared, which gives me b cubed. So my first term from distributing is 12a cubed b cubed. Let's see what happens when I distribute to this second term over here. 4a squared b times negative 2a cubed b. So the 4 is going to multiply by the coefficient in front, negative 2. That's going to become negative 8. A squared gets multiplied by a cubed. That's a to the 5th. When I multiply bases, I add the exponents. And last I have b times b, which is b squared. There we go. And that one's all finished. If I had any like terms, I would combine them. But like terms have to have all the same variables to all the same powers. So this has a cubed, this is a to the 5th, this is b cubed, this is b squared. So none of those match, so I can't combine like terms. Let's take a look at problem b. The problem b has 3 terms, x, x plus 3, and x plus 5. And each of these has to get multiplied in a row. So just like I would multiply over here, let's say I have 2 times 3 times 4. I multiply these numbers together by first multiplying the first 2, 6, and then taking that answer and multiplying it by the number that's left. So this answer would be the number 24. Now it doesn't matter what order I multiply those in. If I did 4 times 2 first, I would get 8, then times 3 is 24, or 3 times 4 first is 12, times 2 is 24. Either way, no matter the order, I multiply them all together, I get the number 24. So the order of multiplication doesn't matter. I always get the same answer. So for problem B over here, I can either distribute the x inside this first term, multiply those first 2 together, just like I did here. I multiplied 2 and 3 first. Or if I don't want to multiply those ones first, I can multiply these ones together first. It doesn't matter the order, right? Just like I could multiply 3 by 4 and get 12, and then multiply by 2 to get 24. I can multiply these 2 first. And that's what I recommend doing for this problem, just because it's easier to FOIL these together when the numbers are as small as you can get them. If I distribute the x first, then I'm just going to have to deal with bigger powers, which may happen sooner than I'm comfortable with. So the order doesn't matter, but I do recommend FOILing first. So I'm going to FOIL these guys together first. So I have x times x is x squared. X times 5 is 5x. That's my first and my outside. For inside, I have 3x. And for last, I have 3 times 5, which is 15. Now here, I have 5x to the first power and 3x to the first power. I'm going to combine those. So I get x squared plus 8x plus 15. And now I've finished multiplying my first 2 terms together. X plus 3 and x plus 5 have been multiplied. So that's just like if I did here. I multiplied those 2 terms together, and I got a solution. So this now has to get multiplied by the number that was in front. So I'm going to take this term and multiply it by this x from in front. So all I have to do is distribute this x inside, and I'm all done. This x has to get multiplied to everything in the parentheses, all 3 terms. So x squared will become x cubed, 8x will become 8x squared, and 15 will become 15x. And this problem's all done. We're going to go ahead and pick up with the next set of problems in the next video.